B, and C. C causes a mild disease and it's not known to cause outbreaks, so we don't even consider it, we don't even test for it. We don't even think it makes many people sick. So that leaves us with type A and type B. Type B viruses do not mutate to different strains. So the type B virus that was here 100 years ago is still here. It's always the same. Doesn't mutate. But type A viruses mutate. And they mutate. They change their genetic structure. Now, if you remember in immunology, when you make antibodies to something, the macrophage grabs it and breaks it down and presents the genetic structure of that agent to the T cells and B cells, and then they make antibodies specific for it. But what happens with the flu virus is that the flu virus changes its genetic structure from year to year. That's the reason why we have to get flu shots every year. And the reason, and what it is, it's what we call the hemagglutinin and the neuraminidase. The hemagglutinin is a structure that sticks out that attaches to your cell. The neuraminidase is an enzyme that eats a hole in the cell that allows the virus to penetrate. So, those are the two important structures. Now what it says here is type A viruses are characterized by two surface antigens. They're known as hemagglutinin, which is H, and neuraminidase, which is N. Now you know the swine flu, we call it H1N1, all right? Which means its genetic structure is H1N1, and then we have H2N1, you can H3N1, you can have H1N2, so they're all different strains of flu, okay? And it's all based on that hemagglutinin. Virologic basis of seasonal epidemics is when new viruses variants occur and frequent antigenic drifts are due to a point mutation. Now what happens here is this. When the virus changes, and I'll explain how it changes, if it only changes slightly in the sense that your immune system still recognizes it, we say that that is an antigenic drift, okay? This is important to know. There may be a question about it. This is called an antigenic drift, when there's only a slight change in the antigenic structure of the virus. So that your immune system still recognizes it, okay? It's just like I saw you last year, and now I see you. I took a year before I see you again, and now you look the same, but now you're a little heavier.
Oh, great.
Okay, so you drifted a little bit. You look a little heavier. You look the same. I recognize you, but you're a little. Right. So it's a slight drift. So when you have an antigenic drift, your immune system still recognizes the virus, and it probably means that you're protected. On the other hand, viruses can go through what is called an antigenic shift. And when they go through an antigenic shift, it means that their genetic material completely changes to the point where your immune system does not recognize it, meaning that it doesn't remember ever being infected by it. And when that happens, then people are now susceptible to the virus. So an antigenic shift is what is bad. See, over here it says in 2001 we had the emergence of influenza A, H1N2, and then what happened is that we had a reassortment between A, H3N2, and A, H1N1. They can reassort, and I'll explain how that happens, and then they can change. So antibodies raised to one variant may offer limited or no protection against the other variant. Symptoms. Now, this is where we have a problem. A lot of people get sick with a cold, a bad cold, and they'll tell you they had the flu. You got to distinguish the flu from a cold. Unlike the virus that causes a cold, and there can be many of them, cold viruses usually cause sinusitis. Cold viruses affect your sinuses, not your lungs. So when you get a cold, usually you start with a scratchy throat, your nose is a little scratchy, then you get a runny nose, and you gradually progress to where you've got a lot of gunk coming down, and you may have a cough, and maybe not a fever, but you may feel feverish, and it may only last for about a week. But when you got the flu, you may have a sore throat one day, and the next day you're going to have a high fever and body aches, and then respiratory. That's the flu, and it lasts for 1 to 2 weeks. Onset of the flu, and the virus attacks cells in the lungs, not the sinuses. Onset is rapid, usually 24 to 48 hours. You're going to have a headache, a high fever, muscle aches, non-productive cough begins, but later becomes productive. The lung cells are destroyed by the immune system, and pneumonia can develop. That's a secondary infection with pneumonia. The flu may last for 2 weeks and cause extreme fatigue. That's not the case with a cold. This is showing you an x-ray of a person with the flu. You can see the white areas in the lungs here where you have congestion. So radiation particles can't pass through. You don't get the dark